Thanks, everyone. Good afternoon. It's great to be in Taipei, specifically talking about security and embedded solutions, because sitting among the experts who are our OEMs, ODMs, and what we do here, it always gives us the enthusiasm to actually talk about security, talk about what we need to do in use cases, but tie it to some platforms and tie it to what you can tangibly show as results in cloud security. So with that in mind, let me I just want to say in advance, given the inputs I got, I wanted to actually stay a little bit technical, but at the same time, get the message out. So please excuse if some slides are a little bit dense, but we will try to actually state the high-level message. When we talk about cloud security, it is not just throwing a firewall into the cloud and calling it a cloud-based firewall, or trying to do some antivirus with traffic being diverted into some central location. All of you know the economics of cloud, the benefits that cloud provides us, scalability, agility, availability, and all of this. Leaving that aside, deriving the economics of cloud requires us to look at security not as a bottleneck, but security as an enabler. So security actually encourages people to move to the cloud to get better cloud deployments. So if I really look at the use cases, data center to cloud movement, cloud security is also about providers hosting data centers, secure EPC if you talk about telcos, where there is hybrid cloud deployments if you are talking about branch offices getting some extensions into hosted private or hosted hybrid clouds. Big data, it doesn't go without analytics and data security, right? And then the list goes on. Specifically, if you look at all of these use cases, let's keep in mind, every use case has 100 security requirements. But if you talk about the top two needs, like data center to cloud, I am moving my assets from the enterprise data center into a hosted private cloud or a hybrid cloud. What do I care about? My workloads, whether this is compute, network, or storage, it has to be secure. I need to be in a position to trust it. And cloud security here is about encouraging me to move my workloads as an enterprise into the cloud to derive the economics of cloud. That's the reason why workload integrity and data security are the top concerns in that first use case. Of course, data security comes with 100% of customers that we met. They always say, you do what you want, whether it's Intel or network providers, whether it is a storage provider, you do whatever you want for cloud security, but as a customer, what they care about first is their information, data in flight, data at rest, data in use. If we don't ensure that, the rest of the stack just goes away in terms of the security solutions. So the swing factors that we are currently in is DC disruption with virtualization and cloud, greenfield data centers that are actually coming up with hosted clouds that I mentioned, and a lot of other stuff. So if we really look at this, this is a pretty rich set of use cases. And my colleagues here will talk about identity, what fingerprinting actually means. They will talk about analytics. They'll talk about threat intelligence in the VDI context, and everything associated with the use cases. But if you really look at the solution for those use cases, there should be something like a hardware root of trust, something that is rooted and attested in hardware, from which the software stacks come up to get you workload integrity and confidentiality, providing you data security, providing you network security, and providing you location control. If I have my workload that needs to stay in Taiwan, if somebody tries to move this workload, physical or virtual, outside into a hosted cloud, outside the boundaries of Taiwan, either OpenStack should be able to stop it, or vCloud Director in VMware should be able to stop it. You should have the mechanism to have that location controls. That's the fundamental part after data security. So with that, let's move on into the scope of the data center. You all follow the NIST models, protect, detect, and recover. There's a lot more to it. But if you really look at the software products and the associated root of trust and associated hardware solutions, now we need to defend the data center with a bunch of components. And by the way, this list of components, they just don't fit in one slide. We did our best to show you, but this is not an exhaustive list. Starting from the management to NOC, network operation centers, and others, going down to storage, network, compute, physical access, and above all, for HPC, supply chain becomes important. How do I ensure that the firmware that we have given to the upstream channel partners goes through the two tiers, goes to the downstream, goes to the end customer without being tampered? And that is critical for supply chain security. So we take care of any of these and then look at that in the context of software-defined infrastructure, high-performance computing, and big data, the three main pillars that fuel our data center growth today. So securing these with some of the primary data center components is the critical piece we are talking about. So if you look at this, you can always stay at a high level saying cloud security needs confidentiality, integrity, ability to recover. But then going to the next level on what the workloads are that you need to protect, you really look at these details. Now, 60% of IT budget from some analyst reports is being allocated to cloud computing. So from physical to virtualized to enabling cloud-based technologies, there's one critical message we always look at here. People say the data center boundary has crumbled, the enterprise perimeter has crumbled, everything is moving out into the cloud. Great. The enterprise boundary has not crumbled. The enterprise boundary is moving with every IoT device you take it with you. The enterprise boundary is moving with every BYOD device, bring your own device, that you carry with you. Essentially, the enterprise is moving with you. It is not crumbling. How do we do the same security that we did in the four walls of the enterprise in a monolithic fashion around the endpoint, around the server? Server is also an endpoint. Around the endpoint, and that is the essence of what you call as a difference in cloud security. We just don't, like I started this presentation saying, you don't throw a firewall in the cloud and call it a cloud-based firewall. This firewall now has to ensure that the policies for this endpoint are carried with the endpoint and you enforce those policies. Essentially, security becomes a ring around the smaller extensions of the data center as they move. So we don't believe that the perimeter is crumbling. It's just that it has become a bunch of endpoints that we need to protect with the same security policies. So you can probably skip the rest of my presentation if we can just take away this one slide. What are the top concerns that we are looking at from a cloud perspective? Ownership and control of data. Irrespective of where data is in the cloud, the enterprise owns it. You talk about infrastructure as a service, PaaS, platform as a service, or software as a service models. There are various levels of controls the IT department gives up, and then the control goes to a third party. So if you're talking about the web application and database tiers of the data center, in a SaaS software model hosted by Salesforce.com, for example, all of these three tiers are in the control, for example, of Salesforce. But data can never be in a third-party control, irrespective of information stored in a third-party environment. I'll give you an example. The German government was telling Amazon, you can have private clouds within Germany, but you cannot host data of German government outside Germany. So you need to create islands of data clouds within Germany if you really want cloud business with us. So the problem there is if you encrypt data and keep the keys with the enterprise, and the data in an encrypted form can go wherever it is, you meet all compliance requirements, like ENISA, ISO 9000, whether it is CSA cloud audit. So it is very critical for enterprise to maintain ownership of data irrespective of where it is. Then the second thing, I don't want to move to the cloud because I just don't trust it. So lack of trust in the infrastructure where you're moving your workloads, and how do you ensure that trust? And that's the second and most important piece where hardware players, OEM vendors, and software stacks, whether it is OpenStack and all the way with Open Daylight controllers, should be able to ensure. This is an ecosystem from the SDKs, from the apps, all the way down to root of trust in hardware. That needs to be assured for actually giving you trust. Fragmented policy in the network. In the four walls of the data center, you have your policies. How do you ensure, even in a private cloud, hosted, say, hybrid cloud environment, these policies are preserved? That's where SDN, securing the SDN controller itself, and then NFV, where network virtualization is about running it on a general purpose server, but running the same firewall solution, running the same switch, running the same router, with still the same efficiency and maybe better security. So we need to get there for us to solve the fragmented policy problem for cloud security. Recovery and cyber resilience. With some major percentage of footprint in data centers coming, say, from a few vendors, compromising the hardware of that vendor can actually mean a brand problem, right to start with. Irrespective of the nature of the attack, and my colleagues from Trend and others, they'll talk to you about how we can get antivirus, anomaly detection, threat mitigation, all of these things. Irrespective of the nature of the attack, you should not brick the server. What it means is the server should be able to recover from a read-only firmware that nobody can touch. Of course, when it boots up from the read-only firmware after an attack, you may not have all services turned on, but still you can reach it. You can reconfigure it. So you should not be in a position where the system administrator has to go to the data center and start changing wires to fix it. So recovery and cyber resilience is a critical piece when it comes to attacks. All right, so if you look at the top three use cases, secure data, ensure chain of trust from the boot process through the firmware, through the virtual machines, all the way to the application. And the third one, secure network functions and secure the controllers that today in a cloud environment operate the network. The biggest worry network providers have is we made SDN controllers, whether it is Cisco, whether it's Juniper, or related network vendors. They say the moment this SDN controller is compromised, you have keys to the network. You can bypass a firewall, you can change network policies, you can do everything with it and create havoc in the network. So protecting the controller itself becomes a critical piece as part of the third element. So here, the key takeaway is to solve the problems that we mentioned in the previous slide, taking the top three use cases. Secure your data, trust the infrastructure, and do everything you need to trust the infrastructure, and preserve your network policies and controller-related integrity policies. And the rest of it follows. Essentially, we just gave you some examples of Intel architecture on which you have to build a few things, some examples of the horizontal deliverables, but these are examples of solutions. But what customers are looking for is the top three use cases. Okay? This is just a slide for your reference, so I'm not going into the details, but compromised data in the cloud, avoiding file system exposure. I was given feedback that this group cares a lot about data security, and we are asked to see how we can ensure, not just at a high level that we need to encrypt data. Encryption is the easy part of the problem. Key management is the difficult part of the problem, right? How do you ensure keys remain in customer control? And if you are looking at file-based encryption, somebody can encrypt a file, object-oriented storage or structured, unstructured data. 6 months back, 6 months later, I'm just giving an example, somebody comes back and says, I need to decrypt this file, can I get the key for it? Loss of key is as good as losing data, right? And the keys have to remain in enterprise control at least. So the biggest challenge we have is, from a hardware perspective, creating a key vault and a key service, and then from a software perspective, ability to get to the key fast enough in a way that it is not fully replicated and it is not compromised. That's the challenge. Encryption, AES 128.256, we can always do that. So essentially centralized key management, technologies like DPDK, Quick Assist, storage acceleration layer, these are the things that help us get to some level of data security. And trust attestation, this is just one slide from the market side I want to show you. For software-defined storage, for virtual machine solutions, and for NFV, I'm still focused on those three things if you really look at the presentation here. Storage, trust, and network. So for those, you can see the revenue and what the cloud security TAM for each of these can be based on IDC, Infonetics, and all these reports. So with this, I just wanted to show you, since it looks like a monologue, let me just show you a location control example.
Geotagging and boundary control in the cloud. This video will demonstrate the control of workload placement in the cloud based on location policies. To begin, create the various tags that will be provisioned to each server. Here we create a country tag with possible values USA and Canada. Next, we create a selection of the specific tags that will be provisioned. In this case, we use the state tag and select California. The OpenStack Hypervisors page has been modified to include a provisioning tool. Here we demonstrate provisioning a host with a selection of tags. This process writes tag information to the hardware. After rebooting the host, the provisioned tags are visible by hovering the mouse over the location icon. Once all hosts have been provisioned with the necessary tags, policies can be associated with image objects to define workload placement. In this example, we've defined a policy for the image SAP HANA California that will allow it to be launched exclusively on hosts provisioned with the SAP HANA and California tags. These tags correspond to the tags provisioned to host Havana AT Node 4. And we can see that the scheduler has launched the instance on the host that matches the policy requirement. If no hosts have tags matching the policy set on the image, as in this example, where we define a policy requiring both the Hadoop and California tags, the location policy will not allow the image instance to be launched. Since no hosts have been provisioned with both the tags defined in the policy, the instance is not launched.
So what you have just seen is, of course, a demo of how you do this. But from OpenStack all the way to the hardware, OpenStack helps configure a location policy saying, I want this virtual machine to stay within the boundaries of a country, whether it belongs to a state or a country. And then OpenStack glance, in this case the scheduler and the attributes, it looks at it and then verifies with an authority in the cloud and then brings up the virtual machine only when it is confirming with the location policies that you have. So you are now enforcing physical and virtual boundaries to make sure your workloads, your data don't move into locations that you don't want. So this is what we say a chain of trust, starting from platform integrity with location control, workload integrity, all the way to runtime integrity. If we can get that chain of trust with a root of trust somewhere, you are saying my application has booted up in a way that I can trust it. My application has initialized in a way that it has come up from a known good value. Well, when you have runtime problems, sure, we have antivirus solutions, we have threat detection solutions. But then what you are looking here is to ensure that from a boot integrity perspective, whether this is just the boot process or all the way to the application, you can be assured that it is infrastructure that is secure. So this is just another, I don't want to bore you too much on this, but this is a 40-second presentation, but let's go through this. People talked about just the hardware integrity, but then Docker, if you take the virtual machines out for a moment, this is becoming popular. Docker, Mesos, other deployments in the cloud. This is a set of libraries that go all the way from the OS to a container and the container apps. So once you verify the identity of the end user, you need to attest these applications in the Docker, attest the OS and services, and attest the apps. So if we can do that, the platform integrity will be guaranteed for Docker. What's the biggest problem for deploying Docker today? It's a good set of libraries, but then multi-tenancy in case of Docker is a huge issue because unlike virtual machines, it is not physically separated from an OS and a memory perspective. Docker intertwines with the containers that it has. So before I conclude in the next 3 minutes, one last 45-second display of how Docker actually can be attested. So please take a look at this one.
Intel is extending the TXT-powered trusted launch capabilities to allow attestation of components beyond the BIOS and the kernel, allowing the Docker daemon itself to be verified during the trusted boot process. During the trusted boot process, the Docker daemon is measured and the measurement is extended to PCR19. If the measurement does not match the expected whitelist value, the host will be flagged as untrusted. A filter for the OpenStack scheduler ensures that container images can only be launched on a host whose BIOS, kernel, and Docker daemon have all been verified as trusted. And with the new Intel plugin for the Docker engine, we can extend the trusted launch capabilities even further, verifying the integrity of the actual Docker app containers themselves. By storing whitelist metadata with the container image, the integrity of this Docker app can be verified before allowing it to launch. If the actual measurement of the container image does not match the whitelist values, the launch will fail. Intel is providing exciting new...
So with that is about Docker security. And like I mentioned before, this is just one slide on the NFV landscape. And I wanted to quickly run to the NFV stack. All the way from orchestration to hardware with DPDK and quick assist. The goals are to protect the controller, protect the virtual switch, because if it's OVS or any other switch environment that makes network decisions, our ability to protect that becomes critical for network in terms of SDN or NFV solutions for the cloud, and then offload some of these performance requirements. So I want to end by saying NIST has a framework. They started with protect, detect, and recover. CSA Cloud Audit talked a lot about cloud security solutions. Now, when you take the approach of proactive security and reactive security, so what does proactive mean? Everything that we talked about so far, make sure you have a known good value, make sure you have policies, IaaS, infrastructure as a service is secure, platform is attested, all of that. So you ensure workload integrity, accountability, and known good state. And these are examples of what workload integrity means, what accountability means, and what known good state means from a proactive security perspective. Security, especially for cloud and cloud security, it's not just about heavens falling down, some attack is in progress, we need to help mitigate it. That's very important. But what is also important is making sure your policies are still within your control, your data is still within your control, your infrastructure is known to be trusted so that you can safely move workloads into various cloud deployments. And then comes the reactive security. Reactive security is a good thing when there is an attack and there is an attack in progress. How do you quickly identify, recover, and actually mitigate other servers from actually getting to that attack? So runtime security, antivirus, DPI firewalls, intrusion prevention, anti-malware, all of these come in reactive security. So if there is an attack in progress, your ability to generate a signature quickly and launch that signature across your ecosystem is so critical. So I will leave you with this slide to say, if we follow this framework, there is no one product to solve all of these problems. It is a framework of proactive and reactive approaches to cloud security within what you can protect before you start your operations, how you detect during your operations, and how you recover should something go bad, and how you get back to a known good state, whether it is zero-day protection in case of recovery from a reactive perspective, or replicating, say, storage states or snapshots from a proactive perspective. In essence, that is the framework we follow for cloud security. Hope you liked the presentation. I'll be around for more questions, but thanks a lot for your time. It's always great to be talking to a great audience like this. Thank you.
Thank you very much for joining us today, Mr. Varanasi.